Run away. Did you dislike one of my videos last night? Yeah. I saw someone commenting and disliked one of my videos. Would you like to change that to like rather than dislike? Good, good. Okay, so thank you, Albert, for doing that. Right. Let's have a look now at the next topic. So, for example, we'll have a look at problems like this. So if we want to solve problems like this, where we have to integrate it now, we're going to have to do what we did in the last lessons, which is simplified. So we can say minus 12 over 3x squared plus 8x plus 4 equals a over and b over. So what would this be? 3x, let me see, so I need 2 and 2. Is it 3x plus 2? Is that right? X plus 2? Will that do it?
Yeah.
Yeah. Will it? 2, 6, yeah, it will, yeah. So I get minus 12 equals a, x plus 2, plus b, 3x plus 2. So if I put x equals minus 2 over 3, that means I'll get minus 12 equals a times 4 over 3. So a is 9? Minus 9? And then if I make x equal to minus 2, that means I'll get minus 12 equals minus 4b. Is that right? If I put in x as minus 2, minus 6. Yeah. So then I get b equals 3. So now this problem can be changed into this problem. Minus 9 over 3x plus 2 plus 3 over x plus 2 dx, which can be changed into these two problems. Minus 9 integrate 1 over 3x plus 2 dx plus 3 integrate 1 over x plus 2. Now that's really good because these are both in your formula book. This integrates to minus 9 times 1 over 3 log 3x plus 2, and this one integrates to plus 3, and this is log x plus 2. This is plus 2 here.
How do we do it with the log?
It's in the formula book. It's one of the rules in the formula book. I'll write the rule here because I've shown you twice before. So for the third demonstration, if you want to integrate 1 over ax plus b dx, that is 1 over a log ax plus b plus c. That's in the formula book. Okay. Now, usually in the exam, they'll put in some limits here, like for example, 0 and 1. So that means we have to put 0 and 1 in here. Now, in the exam, they usually want the exact answer, not a decimal answer, so we have to simplify it. So let's put in the 0 and 1 now. So I'll put in the 1 first, minus 9. Well, that will simplify down to make 3. So it'll be minus 3 log 2 plus 3 log 2, and then, oh sorry, I'm putting in 1 first, minus 3 log 5 plus 3 log 3, and then I put in 0, minus 3 log 2 plus 3 log 2. I put in the 1 and then the 0. Is that right? 3, 5, 3, 2, 2. So that's nice, they cancel. Yeah? They still want you to simplify here. So what I do next, what would I do next? Put the minus 3 up and put the 3 up. What would be next?
Multiply them.
Multiply them, so it'd be log 5 minus 3 times 3 power 3. Next, you would change that into log 3 cubed over log 5 cubed.
We'll take with this out.
Now, usually they have it left like this, 27 over 125. So in the exam, they usually would say in the question, write your answer in the form of log P over Q, or something like that. Now for today, I'm not going to worry so much about this because this is just simplifying. What I really care about for today is actually this part here.
So then the final answer will be
This.
no, but without the limit.
Oh, for today?
Yes.
Yeah, for today the final answer will be here then, yeah. Okay, write this one down and I'll do another example. So that was A here. In a moment, I'll do C. Remo? Yeah, you're Remo, aren't you? Yeah, just get off the phone. Okay. Can I do the next one now? Yes? Yep, okay. Let's have a look. So in C, we want to integrate minus 6x plus 22 over x squared minus 10x plus 25 dx. Okay, so first piece of business, we'll say minus 6x plus 22 over x squared minus 10x plus 25 equals, and here the first factor is x minus 5, but the second factor is also x minus 5, so here we have x minus 5 squared. A and B, we'll say. So we got minus 6x plus 22 equals A times x minus 5 plus B. First we'll make x equal 5. Then that means we'll get, yeah, this will be minus 30. So minus 8 equals B. And then next we'll make x equal 0. So that means we'll get 22 equals minus 5a minus 8. So then that means, let me see, a would be minus 6 though?
Yeah.
Or 6? Minus 6. Yeah. So now that I have my A and my B, I can change my problem into this. Integrate minus 6 over x minus 5 dx plus integrate minus 8, minus 8 over x minus 5 squared dx. Okay. So this one here, let's see, let's get a green. Yeah, nice. This one here is okay because this one is in the formula book. But this one is not. We'll have to do something special to this one here. So, let me go to the side here. Let's do the first one. The first one will be minus 6 log x minus 5. And then the second one here, we don't know. It'll be minus 8 dx over x minus 5 squared. So we have it half finished, but we don't know what the second one is. Any ideas on what to do for the second one? Any ideas what we could do for the second one? U, yeah. U is what? Yeah, you can say let u equal x minus 5. So du dx equals 1. So that means du equals dx. So this will be minus 6 log x minus 5 minus 8 du over u squared. Okay, what's next?
Minus 2.
Yeah. Change this into u minus 2 du. Okay, Malik, so what does this become then?
Minus 1?
Yeah.
Minus 1.
Yeah. Now what should I do next? Well, I should replace what the u is. The minuses cancel.
8 over u.
It's 8 over u, yeah. And then finally, what did I say the u was? So this is my final answer.
X minus 5.
Yeah. Plus 8 over x minus 5 plus c. Up? You mean left? Oh. So lean back will also do it? Okay. This is what you get in the exam. You know, these would be common exam questions in section B, and sometimes, but not usually, in section A.
I think it doesn't need some time.
It needs some time, yeah. So you don't really get this in section A, although I have seen it once, at least recently. It's more commonly section B. Victor! Okay, you got this? Let's see what else we can do. I'm going to do I next. Yep. Yep.
In the answer you wrote minus 1 over x minus 1.
Did I?
Is it 8 or is it minus 1?
Oh, sorry, that's a typo. I have two minuses at the back. It's a plus. Oh, and I see what you mean.
Minus 1 over...
And I should have 8, shouldn't I?
You did 8 or minus 1? You did 8 or
Yeah.
So is the answer minus 1 or?
No, I don't feel like I made a mistake here with the 8. Well, the other thing is, as well, Remo, this one has two answers. I don't think that's what's happening here. I think it might be just a typo. Doesn't matter. Okay, can I do the next one?
Yes.
Yep. Okay. So I think I said what one did I say next? I, was it? I. What's wrong? Great. I. Integrate 6x squared plus 15x plus 45 all over. Now there's a minus in the bottom. Can you see that? Everything has a minus in I. So I think I'll just take the minus out in the front here. Changes into 3x cubed plus 13x squared plus 28x plus 8 dx. Pony, can you hand me the calculator? Thanks. So, guys, come on. Albert, you too. Are you listening, Albert?
We are seeing why the top one going to take the extra minus out.
The minus is on the bottom, so I took the minus out from the...
You need to change the
Oh, no. I can take the minus out the top or bottom. For example, if I had p over minus q, I can change that into minus p over q. Or if I had minus p over q, I can change that into minus p over q. Yes, Albert? Yeah. So I took the minus out from the bottom. Anyways, I can change this into, if I factorize with the help of my calculator, okay, so let's check with the calculator. The first factor is calculating 3x plus 1. And then that's it. Here you go. So, do you remember what do you do when this happens, when the cubic only has one factor? Correct. So, now on the side to the left, we have 3x plus 1 divided into 3x cubed plus 13x squared plus 28x plus 8. Right, what's first? X squared, 3x cubed plus x squared, and I'm left with 12x squared plus 28x plus 8. So next should be 4x, 12x squared plus 4x, 24x plus 8. What's the last? 8, isn't it? 24x plus 8. So this is the second factor. So if I go back to the question now, x squared plus 4x plus 8 is what I'm missing here. X squared plus 4x plus 8. How many coefficients here?
2.
Well, really 3 because there's a 1 there. So how many on the top? 2? It's a quadratic. On the top should be linear. So I must have bx plus c. No choice. So when I multiply, I get 6x squared plus 15x plus 45 equals a times x squared plus 4x plus 8 plus bx plus c times 3x plus 1. Okay, so firstly, let x equal
Minus 1 over 3.
yeah, minus 1 over 3. And this will give me the a. Okay, can you do that for me, please? Can you give me the a? for A. Good job. So next we put x equals 0, and what do you get for that? This will be 45, this will be 8a, this will be 48, so this should be minus 3, that's a 0, so C, and the minus... I lost it. Can you get me the B, please? Oh, sorry, no, this second one would give me C, not B. Alright, so give me the C, please. What the heck is happening? It's a little bit too realistic. Go ahead. Hang on, come back. Okay, what did you get for C? What did you get? Minus 3. And B then finally? You got it, Tony? The B? Come on, Raymond, don't just sit there. Give me the B. You got your calculator? Alright, who has the B for me, please? Jinwei, get me the B. Do you have B? Get me the B. The 0 can be fine, yeah. So B here is 0. So, our problem was to integrate this here with a minus. So now our problem has become integrating this. And also don't forget, I need to put a minus in my answer at the end because there's a minus there. So let me just write out what we have here for A and B. We now have integrate 6 over 3x plus 1 dx plus integrate minus 3 over x squared plus 4x plus 8 dx. But don't forget there's a minus on these, so this has now become integrate minus 6 dx over 3x plus 1 plus 3 integrate dx here, x squared plus 4x plus 8. So this is now our problem, which actually is easier than what we had at the start, which I'll do now in a moment. Alright, so the good news is, here, formula. Bad news, here. We need a substitution again. So let's do the first one. What do we get here? Minus 6 times 1 over 3 log 3x plus 1 plus that other ugly thing. So that equals minus 2 log 3x plus 1 plus that ugly thing.
Can we go on?
Yeah. Right, so let's work out this ugly thing here. I suppose it's 3 times the ugly thing, whatever it is. Any ideas on what to do for that integration? Again, it's let u equal to...
Square plus 4x.
No.
1 over this.
No. Oh, we're getting desperate now. So let me do it on the side here. dx over x squared plus 4x plus 8. Any ideas?
Complete this.
Thank you, Leon.
What?
Complete the square. X plus 2 squared plus 4. Now what's next? Yeah. Let u equal x plus 2 over 4. So that means you'll get du dx equals 1 over 4. So what does dx equal? 4 du. Sorry, you can't see that. U equals a quarter x plus a half. Yes? Do you remember how I did this? No? This was like 2 lessons ago. It's square root the first over the second. It was the lesson with the tan inverse in it. It was page 70, question 4. Have a look at that. Page 70, question 4. Can everyone look at page 70, question 4? Have you seen this? So we've done this already. This is the problem for the exam, is remembering what and how. I think we did it last week, wasn't it? Possibly. Ah, yeah, that thing.
So that's fine.
Yeah, me too. Right, continue. So what is du dx here? It's a quarter, yeah. So we have, what's dx equal to? 4 du. And also, what does x plus 2 equal? If I use this, what's x plus 2? 4u. So if I put these two back in here, let's see what I get. I get integrate 4 du over 4u squared plus, now what's nice about this? What's in everything? 4. So I'm left with integrate, yeah? Oh no, it's not. It's not 16, it's 16. Go back. Here. Yeah, that's right, yeah. Oh, sorry, small mistake. It's not 4 here. What should it be? 2. So this is a 2. So this is a 2. Yeah. So it just changes this to a 2. I'll put it in green for you. This to a 2 and this to a 2. Okay. If you remember the rule, it's square root the first over the second. So square root of the first part is x plus 2, and square root of the second part is 2. Okay, so what do I have on the top? What's on the top? 2 du. And what's the first piece? X plus 2 is 2u, so 2u squared is 4u squared plus 4. What's in common? What's in common? 2. So I'll be left with that's gone, that's gone, that's gone, and here is 1 over 2. What do I get when I integrate 1 over u squared plus 1? I get tan inverse u with a half here. So this can go back up here as minus 2 log 3x plus 1 plus 3 over 2 tan inverse x plus 2 over 2 plus c. Now I know that's long. Yep, question? Here is x plus 2, and we said x plus 2 is 2u. So when I square it, I get 4u squared. I replace the x plus 2 with 2u. Now I know this is long, but this is exactly what you get in section B. Usually in section B, your answer has a log and the tan inverse in it. This is actually quite normal for the exam. It's long, it's difficult, but this is what you get in the exam. This is life. Life is difficult.
How many units you choose in section?
See, you're already thinking, I'm going to skip this in the exam, but this is not the way to be thinking.
Just focus on the statistics and you get that one.
You don't know this because sometimes you might get 2 calculus questions and you can't avoid it then. It's bad strategy.
But how many units you choose?
You have to choose 4 from section B
I think
out of
like
6.
maybe 2.
But you're making assumptions here that you won't get this in section A, or that the other 2 questions are worse than this, possibly.
And you should have some cushion from first semester.
Yeah. Which maybe you also forgot how to do. Yeah. Now, wait, hang on. Sit up, Albert. Did you put your stuff away? I'm not finished, I'm still doing this question. I have one little thing left to do. Marcelo, there's loads of time left. What are you doing putting your book away? Come on, Albert, sit up. Thank you. Now, in fact, it's usually a little bit worse in the exam, because in the exam for this question, they'll put in some limits as well, like 0 and pi over 2 or whatever. Well, I want to show you an exam question.
But actually it's good because we can check by our paper.
It's good because you can know if the answer is right, because the question will often say, show that this simplifies to this. So then you know if you get full marks. This has advantages in the exam. Past papers.
You already know how to do it.
I know how to do this because I've done it like 15 times now.
No, it's not a problem for you, for us.
I know. Huh? I don't know, because I didn't teach business in intake 1. It's a different exam. Here, let me try and find one here.
No, I mean, you know that paper that if you want to
Yes,
do we get this or do
if I want to. Depends how I feel. Right now I'm not feeling so great, so ask me later, okay?
We don't know anyone like who will study next year. Yeah.
Right, have a look up. Let's have a look here. So you can see in this exam there was a simple partial fractions in section A. And in section B, no, not in this year. Let me go back a bit further. So, 2000 and
You have from 2006?
yeah,
Long time ago.
it is. Yeah, here's an example. I know.
So,
Hold on, relax.
but actually this is nice because they give you the last thing.
Now, listen. Before you freak out and die, just listen to me for one moment. So you can see the first part, let's see, is 4 marks. Now that's actually quite good because you get 4 marks for doing what? Finding
Just
A, B, C. And also, what have they given you?
The root.
They've given you the factors. So this is good for 4 marks, okay? Now, yes, the next part is tricky, but the good news is you already have the marks for the A, B, and C, so you're already starting later in the question. Really, this question is saying integrate this, But if you have your A, B, and C, it's the same as asking you to integrate these three. Now the first one, do we know what the first one will be? Yeah, what type of thing will this be? This will be a log. This one here will become, it needs a substitution. What should you let u equal to here? X over 2. And what will this become? It will become a tan inverse. And here, anyone know what to do here? For substitution? No? Let u equal x squared plus 4. And this will become a log. Because here, I don't know if you remember, but I said whenever the top is a derivative of the bottom, then you should let u equal to the bottom. So what's the derivative of x squared plus 4? 2x. So the b would probably be 2. But even if it wasn't 2, if it was like 4, 4 is 2 times 2. So you still have the top as a derivative of the bottom. So this will become log, this will become log, and this will become tan inverse. So when you put the limits in, these two logs should simplify to make this here. And where do these two come from? From the tan inverse. One of the tan inverses will make a nice number, that's this one here. But when you put in the next limit, the tan inverse doesn't become a nice number, so they leave it like this. Okay? So although it's long, I do think it's worth the points, because how many points do you get in total? 10. If this exam had 100 marks in it, how much is that? 10%. So one question is 10%. You don't get that anywhere else in the exam. And that's actually a good thing, because if you get this at the end, that means you've done it right. Which means you know you've got plus 10. So this is a good thing in the exam, I think. Not necessarily something to avoid. Wait. I want people to be practicing these, so I want you to do, 3 or 4 of these at home. Now I'm not going to make you do it, and I'm not going to check. But wait, you're not listening. You're thinking about lunch. Have you got lunch now? Yeah, so this is what you're thinking about. Wait! Stop moving! Thank you. Now look, earlier in the lesson, lots of people forgot, like here, about what substitution to make. And lots of people forgot the substitution here. In other words, I don't think people are practicing enough at home because they're forgetting what to do. And of course in the exam, this is a very big, stop moving, just look at me. No. Everybody is forgetting what to do because I don't think people are practicing enough at home. We still have a few weeks before the exam. Please use this time to practice these because you will forget what to do in the exam. You already forgot what to do and we only did it a week ago. Okay? So you know you need to be doing revision. Okay? Now get your lunch.